What's up, guys? Welcome back to this third part of this TypeScript course that is going to teach you how to navigate the TypeScript environment with Lens Studio. Today, as promised in the previous videos that if you didn't see, I highly recommend you to take a look at before to look at this video. We're going to take a look at an example project, part of our repository that you can find online and Spectacle Sample. And you can find also these projects in the homepage of Lens Studio when you just get started. These projects are just like a collection. I just take the chance also to explain a little bit what this is about. This project is very much a curated collection of starter projects that help you to just understand what are all the capabilities of Spectacles. There is so much stuff. Of course, I cannot cover them all. Today, we're going to cover one in particular called Essentials. This project is great for a very particular reason, which is it's really like the essential part of all of the scripts, of all of the TypeScript ways to do things. There is also the respective utility done in JavaScript as well, if you're more comfortable with JavaScript. But this kind of close up our TypeScript class, our little TypeScript course, because in the previous episodes we took a look how to generally understand TypeScript as a vanilla TypeScript point of view. What is TypeScript about? How to do like things in a very fundamental way. Then in the second part of TypeScript of this course, we just took a look also how to relate all of those TypeScript concepts into a more Lens Studio vibe understanding. And in this part, we finally take a look at things that we're doing in Lens Studio directly. So we're gonna take a look at action items that we can literally just take in order to achieve what we want to do in our lens. Further ado, we took a look at just codes in the previous episodes. Let's take a look at Lens Studio and how does this work. So whenever you will open this project, you will see all of these disabled scene objects. These disabled scene objects are parents of a series of utility. So consider this to be almost like a documentation that you can go through. And every one of these parents has a lot of little demos regarding specific components. So for example, I'm gonna go and just start one by one. This video will be really focused on going deeply into this project. So there's gonna be also the timestamp below. So if you have one particular argument that for you is more interesting than other ones, feel free to skip ahead. But also, since we are starting again, and I never say this before, but please, if you find this valuable, subscribe to the channel. I know it's kind of cliche, but it really helps, so please do. Okay, let's go through it. The first part of this project focuses on accessing component. Accessing component is very important for multiple reasons. The first one is that it's slightly different from Unity. So you might, if you come from a Unity background, you might run into some cases where you get frustrated and you're like, how do I access that component? And the other thing is that differently from Unity also, I always come from this background of Unity, so sorry if I mentioned it multiple times, but in Unity you do everything in C#. You never go out of that language. It's very rare to see. But here in Lens Studio, I happen a lot of time to be working with JavaScript and TypeScript together. So accessing one component and the other one, it's always very helpful. Also, you find all of this information in the form of documentation. If you go on this page, that is part of our docs, we have this section here that is scripting. We have the scripting overview and everything. But if we're just going through what we are trying to see now in Lens Studio, we have a TypeScript section. We also have a JavaScript versus TypeScript section here that shows you how to access things. And then we have the accessing component section that is really much the focus of what we're looking at now, and also gives you practical example, which are the examples that we're looking at in this project. So everything is connected together and is consistent. So going back in here, I wanted to show what happened when you just rerun this utility. This utility shows you that the parent scene object is not null. There is a parent, there is a child, and then this child hold a render mesh visual component. Very helpful to know. The thing is that here in this case, we also get the type name. So we just don't get the get component in this way. Notice that we get the render mesh visuals, and on top of it, there is component. This is mostly working with every component. So component, render mesh visuals, and render mesh visuals is the name of this component, which is attached to the object, to the scene object. So just so you know how this works. Then we have a lot more examples. This is for JavaScript, and let me see. Maybe I don't want to go through all of them, but maybe something you should know is using required and using type name. Actually, what I wanted to do is show the user required, but also I wanted to show you the difference between declaration and without declaration. So if you go using require, this is what you are expecting. You're just doing the hard work at the very beginning. You're requiring the type in the beginning. Then you just basically have your required type as a key of component name map, and then you will see that this type name comes handy when you actually are trying to get this component. So same thing over and over again. You see that there is a type name, and then you just like get it whenever you got it. Here you just like reference in the beginning here if you don't know that specific component. This is a custom component, so I just wanted to offer you also an example to accessing custom components, because you might have your own component and you say, okay, so I have a new component, how can I access it? If I make a new one, you would expect maybe that you have to write component dot to your new custom component. No, of course not, because that's custom. So you need to access it in these ways. And there are many, many examples. This is a custom component for JavaScript, for TypeScript. And of course, like these examples tackle a scenario where you cannot, for some reason, input that component into your inspector. When your project becomes of a certain size, you make use of things like prefabs, and it's very common to see that, of course, you cannot reference right away things in the prefab because the prefab is not part of the scene yet. So what you will need to do, you will need to dynamically reference scripts and components, and these utilities really allow you to achieve that behavior. All right, so another thing that I want to show you is this with declaration and without declaration. This works equally. There is just a different structure between the two ways to do it. So if you go in accessing JavaScript from TypeScript with declaration, means that you will need to have a sort of declaration mid-file between the two files. So you see here that you have a declaration and then you have an interface. Then you have the component A, which is this JavaScript component. And then we have the component B, which is this TypeScript component. So look what is happening here. So the TypeScript component is importing at the very top this JS component A from this path. So nothing crazy here. And then once we imported it, we can once again referencing inside, like here, we can finally have this type that is recognized, and then we can do everything we want with it. But to do that, we will need a declaration file, which is the file that allows us basically to interface our, in this case, JavaScript component with TypeScript. So just so you know, in this way, we will need to have this kind of in-between file. If you want to do that without the declaration component, we just have JS component A and TS component B. Let's see the difference. There is not like there is actually not any declaration. Let's see the difference. So let's go and see the JS component A. There is actually not JS component A reference here. So if you just like search for it, you will see that there is not this component, because we actually just reference it like basically using any. And I don't recommend to do this. Actually, I know that this is what more files like the with declaration. I actually recommend using this because that actually declare a sort of type that you have and you're importing it correctly. I actually like a lot more this one here. Then you can reference this because you have this declaration at the top. So yeah, this is the way to do accessing things from JavaScript to TypeScript. This is instead the inverse. So this is accessing TypeScript from JavaScript. This is another, sorry, this is the one that I showed before. No, this is not. So this is not using the declaration, but we have the input script component ref script that is here. And then we have this TS component that is the one that we are trying to access. So in the final, we have accessing TypeScript from TypeScript, which is probably the easiest scenario. Sorry, I kind of like confused myself, TypeScript from JavaScript, JavaScript from TypeScript. But what I meant here was like accessing JavaScript from TypeScript with declaration and JavaScript from TypeScript without declaration. So we have a TypeScript file where we're accessing JavaScript. And it can be done in two ways, and my recommendation is with declaration, because you actually know the type of what you're importing in a way. You know better, you don't just do any. Then we have accessed the TypeScript from JavaScript, which is very straightforward because, as we know, TypeScript is a subset of JavaScript, so nothing new under the sun. And then we finally have the most common way to accessing components, which is TypeScript from TypeScript. So that's of course, the recommended way to do things. We need to import, of course, the script so we know the type, and then we declare a new type, and then the variable, and then eventually the value of it. And we just, sorry, not the value of it, and then we need to reference it in the in the inspector. If we don't want to reference it, we just do another attribute that is called undefined. Sorry, not uncontrolled. Undefined will allow you to leave this field empty, but even there, recommended just in certain cases, not always, because you want to always know what you're doing. All right, so we went to the access component. We see that we have other chapters to go through. So I hope that this was kind of like a little bit, like gives you a little bit more of confidence in terms of accessing component and starting to do things in Lens Studio like you would do in Unity, or just starting to be more flexible in how to access components. The second part of the second section of this scene hierarchy shows you how to create animations. So LS-Tween is the recommended way to do things. Why it's very flexible is a library which is super easy to use, and you can do almost everything you need to do with animation. The catch is still scripting, but also this series is about scripting. And so I hope that once you understand those 2 or 3 things, you can just apply this to everything. If LS-Tween is a package that you can find on the asset library. So if you go on asset library, you go in spectacles, you will find actually LS-Tween, which is here. Where is it? LS-Tween. Yeah, there you go. This package is I highly recommend to keep it here and keep it packaged. But eventually, if you want to start to play with animation, what you could do is just make a copy of these examples and just making your own modified version. So you have it like in your now I just made a copy and it copied directly in my asset. So when I go back and I just go into my assets folder, we see that we have here the example chain tween, and imports from LS-Tween, of course, because we have actually this package. We will need to change these references, so I'm just going to do it also for you so you understand how to do it. So actually we go into this, and I believe that's the first folder. Yes. And then we will do this, and I believe this is rotation, and then we're good. This is something that you might find yourself to do quite a lot of times, so I just did it for you. Whenever you copy paste something from the packages to the asset, you might need to update these paths if they're not just updated for you already. But this is the good way to do things, because you keep your things locked, and eventually you just get the new version of LS-Tween, and you don't want to mess around with the package itself. So good practice just to have your own modified version. You actually want to do something like this. You want to just rename and just do something like modify it. So you know that it's the one from LS-Tween, but it's your version. In terms of patterns on how to use this is very, very easy. Let's see what's happening here. So LS-Tween rotate offset, LS-Tween scale offset. It's basically a function that you apply in this way. So you see, let's see the pattern here for a second. We are all on a wake here. We get the transform, we get the scale. So very, very easy. Then we create either two basically variable, two function. One is the rotation offset and one is the scale offset. We did not apply those yet, but we will apply with rotate tween. So rotate tween chain, scale tween, and scale tween, rotate tween. So the chain will be another thing that is chaining basically two things together. And then we have the rotate tween start. How does this work? Maybe it's hard to understand from this point of view, but scale offset, if we just hover on it, it gets three parameters. The first is the transform, the second is the offset, and the third one is the time. This is very, very common across a lot of functions that I've seen also in Unity for animation. And this is for rotation offset. Let's take a look, for example, and in the example that I modified here, so prefab instantiate tween, meaning that when you instantiate a prefab, that's what it's happening here. So let's focus on this prefab specifically. Let's see what happens here, instantiate, and just show it this way. This might be a little more structured, like an example, so let's take a look. But it's still using the same way to do things. So let's go into the animation and example prefab instantiation. This might be something you find yourself doing. That's why we added it here, because this example takes the package and then does something slightly different. So we start and we launch this function on awake. What this function does, creates an instance of the prefab, and then it gets the transform, and then set a local scale, sets a local position, and then uses again an LS-Tween function that is scale from to local. So from this transform scale to this max scale in this animation time with this kind of easing. And on start, just print this because I want to see what is happening, and on complete, print this, and just do that. You don't need to do this. This is just a print thing, but you will just say start here, for example. Then here I reference new rotations. So I'm gonna create 2 quaternion, and I'm gonna just like create these 2 rotations, start and end rotation, and once again use the handy function from the package, rotate from to local, and then it's gonna ask me about how I want the easing, and then on start I'm gonna just print. I'm not gonna do anything, and then on complete I'm not gonna do anything but just print again what is happening. So repetitive pattern. I'm just gonna go through 1 or 2 times, but now you get it. You always get an ls tween dot, and then you have a function that does something, and this function requires you some parameters, and once you set those parameters, you're pretty much good to go. All right, animation is done. Let's go on hooking up button events, and which is also very similar to hooking up gesture events. So we're gonna just go through these together. Hooking up buttons event, so click the button to instantiate the prefab. So now instantiate this cube that we see behind us, that we see behind the panel. I always like to look at the TypeScript version because this is a course about TypeScript, and we highly recommend to use TypeScript. Please use TypeScript with Lens Studio. And so in this example, we are hooking up a button, and we are just subscribing to a button click event. Something super common, so of course we need to include it in this essential project. You will see how this works. So on awake, we have a start event. Another recommendation that we have is always like doing things on start, never on event. Because on awake, never on awake, but always on start. If it's a small example, that's okay. But the thing is that when things get more complex, you might actually need to go through a lot of objects that are initializing before to be referenced. This is something that I've seen a lot in connected lenses. Something is not working just because that object is not being initialized. So here on start, let's see what happens. We create an event callback function for the create button. Forget about these logs. This is just logging stuff. So nothing crazy. Nothing crazy going on here. But what you need to remember is that whenever you have this interactor event called onTriggerStart callback, so we have onTriggerStart callback and onTriggerEnd callback, which is basically selected enter and selected exit if you come from a Unity background. This create button on interactor trigger start call this trigger start callback. So let's see what is happening here. So this is the formal. This is how you just subscribe to a button. Basically, you can take this away. So you can just do this eventually if you want to simplify things to the max. This is really like the old formula that you need to instantiate to a button. You have basically an arrow function and gets as an argument this event interactor event. Then this create button, which is the reference that we had in the beginning as an interactable. So under the hood, the button is always an interactable. On interactor trigger start, we just have this callback, which we define here. So, and then we do anything we want during instantiation. This is the function that we are calling in that moment. So the instantiation, in this case, is just instantiating a prefab, calling it a certain name, and just adding a delay event that will destroy the object after X seconds. So this is a destroy delay, which is the beginning, which I believe is 5 seconds, yes. So very common operations, and we have it here packaged for you. Very easy for you to understand. For the gesture, things are very similar again. So this is actually pretty much like the same example of instantiating things, but instead of using onCreate button and instead of adding the create button callback or the trigger enter callback, we actually have something called pinch down callback. So we define the pinch down callback in the beginning, that is this on left hand pinch down. Okay, so this function is actually something that we built here. It's a custom function that we just like define. And then the rest is always the same. So all you need is really this. Let's remove the noise of all of these logs. All you need to know is really this. So again, arrow function, this on left hand pinch down, and then on pinch down callback. So this is another example for doing that. All right, so we know how to animate object, we know to hooking up gestures and buttons, we know how to access components in Lens Studio. That's quite a lot to know for doing a lot of things. I hope that this really is going to empower you to really like establish yourself and your style, and starting from here and go for all the direction you want to go. This new chapter that we're looking through here is about instantiation. Instantiation is something also very essential to all of this game Offline Studio, but generally game development or like app development, spatial development, very, very common operation. In this case, we wanted to go a little crazy and we really gave you a lot of very fancy instantiator patterns. So without going into the details of how to instantiate, which we already saw in the previous example, by the way, this is just like formulas of space that allows you. This is just geometry basically in space and allows you to instantiate all of these objects according to certain patterns, which is usually circular, inside of a cube, outside of a cube, along a line, and so on. So here we have a lot of examples that are very cool. This is perimeter instantiation with fixed arc length. This is a circle. Let me check. Circle slicing. So this is kind of like a pizza instantiation. Instantiate along a line. This is very, very helpful for a lot of utilities. Along line with fixed distance. Then this is a 2D grid. Let me see where it. Oops, instantiate on 2D grid. Let me see if it turned on. So this is a 2D grid. This is the enormous grid in front of us. Then we have instantiate on 3D grids. So this is more of like a three-dimensional instantiation pattern. And then we have random point inside of a box. Then we have random point inside of a sphere. Random point inside of a box surface. Random point inside of a sphere surface. If it's not working, probably the child is turned off. Random point inside of a sphere surface. Simple circle area instantiation. So into the circle area, so it's like 2D. And then finally we have square area instantiation. If you want to do some sort of like blocky games. And then we have collider instantiator. So this is basically things inside or outside the collider, and you can visualize the collider here and you see what's happening inside of the collider. If you wonder, oh, how can you see actually the collider? It's very simple. You gotta use this show collider checkbox, which is in the physics collider. So this will allow you to show and hide the collider. All right, we have instantiation actually on our side now, so we can start to look into some mini demos. We wanted to also showcase not just how things are done in terms of like these components, but we always wanted to contextualize how things could be used. So here you have actually quite a lot of examples that show you how to use this if you're looking to build like actual application. So in this case, we have the first example, which is a dot product. So am I facing this object or not? You see that whenever I'm facing it, it turns red. And when I'm not facing it, it turns blue. So something you can take a look and just like modify according to your taste. I think that there is a threshold in degrees and so on, meaning that if I'm looking probably outside, I think the rule of this one specifically is whenever I'm less than 5 degrees in the, I'm looking at this object, less than 5 degrees is turning into blue. Whenever it's more than those 5 degrees, it's gonna turn red. So this could be very helpful when you are disabling objects that are not in field of view and things like that. Then we have drag and drop. So this is a modified manipulation example. If you remember, if you ever look at SIK, we actually look at it last chapter. SIK has a lot of utilities and interactable, including manipulation interactable. In this case, this was a modified way to build an app where you just have still the on manipulation start, but on manipulation end. A lot of components got disabled beside the physics, and then this happens. So this is drag and drop. Drone behavior is a little bit of a tether, again with another object, so a very fun behavior if you're trying to create some relationship between objects like following. This is something which I highly recommend always for when you are attaching things to hands or any object that you know is going to move very fast or maybe outside of the point of view. I think a very common use case for XR, for VR and AR, is like attaching things to our hands or part of our body because we want that virtual content to react in a certain way. I actually saw the other day on our Reddit a very interesting game where you are holding a spaceship with your hand, and with this spaceship you're just like driving the spaceship in place. My great recommendation is, instead of just like instead of attaching this object as a dry like parent-child behavior, like a parent-child relationship, what you want to do instead is having this utility called Match Transform. It's gonna let your app feel very professional, very smooth, and people are gonna love it. So use it. Previous and next. This is something that I've seen in a lot of different apps. You want to use this kind of like back and forth because you want to show a gallery of objects. So nothing crazy, but probably very helpful, and you don't need to reinvent the wheel. This is the Snap Saver game. So whenever you start this little game, you will see some object like starting to go against you, and whenever you crash into them with this collider, you will earn some score. So this is also basics for very classic game modes. Direction shadow. This is something that we saw in another video as well, but we included in this utility. This could turn into a very interesting game as well, but what is happening is that there is this directional holder that gets another reference in the scene, and whenever we move it, this light is just reacting on the surfaces accordingly. So this is more of a world query model modification. World query model is that kind of world mesh component that works on spectacles and allows you to detect all of the meshes that are in your environment. Raycast Painter. This is another classic here. So let's go back and see what's happening here. Basically, Raycast Painter allow you to check how it's happening here. So this is just like shooting a ray from your point of view and just like painting on a precise area that you claim to be the area that you're trying to paint. So I assume this is a plane, and actually I feel like whenever you get out of the collider of X amount, it's gonna stop painting. So this is very, very dry example, but does the job. And of course you can make this a lot better if you want to do some games or some customized application. This is another raycast. So if I look at the object gets bigger. If I get out, it gets smaller. This is another very easy example just to get you started. And finally, we have our archery game, which works with this closest point online function. That whenever this, let's say now it's just I put it in this way to make things easier for you. But let's say that this is in the other direction, so it's on the z-axis. Just imagine you charge for your arrow and then you shoot the arrow. So something like this. And we're done with MiniDemos. Now in physical collisions, we collected an example that we actually showcased in another sample called public speaker. But in that example, this doesn't really appear to be so like, let's say it's not explained in such good terms because it's just part of that application. So here we just recreated in a more comprehensible way that really shows visually what is happening. This is an interactable and could be any object. We just make it manipulatable, or just a we make it like easy to manipulate because we wanted to show this example. But anytime that this object enters inside of this cube, this object that you see at the center, which is sticking to a line, it's just copying the Y position and it's just like going with it. And just imagine that you attach to that object basically a button, and this is your soft button that is a kind of like a soft button strategy, which we also highlighted in another video called soft button. But I think that is quite an old video, so we kind of remade things a little properly for you, and we included in this library of essential utilities. So here is for you like kind of like a soft press, and you can change a lot of parameters. How does it work? This needs to enter from this direction inside of the box. If you enter from another direction, it won't work. Whenever it enters, this attached to our, let's say, traveler, and then whenever the traveler is out of this collider, the behavior is reset, and this slowly goes back, the guy at the center goes back to his initial position. This example is interesting because it kind of shows how to do things using a mix of collision, so to get the boundary of the space, and also not using only collision, but also using some distance check, which really helps you to make things feeling a lot more natural and smooth. Then how to not forget the raycast. So simple raycast behavior. We are just raycasting straight to this object, and as you can see and as you can tell, whenever we hit this collider, this sphere just like stick to that point of collision. So even here, it's pretty much very controlled. So we are actually raycasting only on this object. So that's why we offer this example, because we're not world meshing everywhere. We're just sticking to this object particularly. Then big request, RuntimeGizmos. In Unity, there is this concept that you just basically write gizmos.sphere, gizmos.line, gizmos whatever, and you see in your scene something like this. Unfortunately and unfortunately at the same time, Lens Studio works a lot different. The scene view has a very different role than the scene view that Unity has, because we have this constant compilation here, and we don't need to play and build, or play or build like we would do in Unity. So trade-offs. There's not the best. I'm not comparing and I'm saying this is better, this is not better. I'm just saying this can be done in both ways, and we offer also these in Lens Studio. And in this particular line of examples, we have line, closed polyline, circle, spline, and spiral. So go crazy in terms of building spatial lines that can represent your logics. Maybe you're trying to debug and you can debug in the preview, or if not, it's something that you can actively use and render on device. Then we have a little chapter for snapping. And this is something that I think it's kind of splitting 50-50 developers, because I've seen sometimes people loving snapping behavior and people hating snapping behavior, but it's good to have. So in this case, we're snapping this object to a line. So let's imagine that you're trying to create, I don't know, like a swapping behavior, like a sliding behavior. You want, let's say that this cube is your hand, and you're just trying to activate something whenever this red dot, which is the projection of this object, gets to the end of that line. So what do? We just do this, and then that triggers what we want. I've been out of the scripts for some time, so let's go actually to go check out what's happening under the hood here. Let's go into snapping behavior, snap to line. So the one of my favorite utilities, and I'm pretty much like using this everywhere I can, is the closest point on line. This saves you so much, and I feel like also gives you such a high level of precision, which is really underrated to me as a function. So this closest point on line, which you can find, where is it? You can find here. This gets the line direction, and this gets the point that you're trying to project, get the line start and the line end, and then finds finally the other point that is across the start and line end. So this is very cool. In my opinion, one of the best things to do for XR in many occasions, like keyboard, sliding, swapping, like a lot of different interaction, in my opinion, works very well with this directionality, with this utility that gives why I like it, because clamps to position, so it keeps it very much like controlled, and also gives you directionality. So whenever you want to do a gesture in a particular direction, you just force it to be in that direction, and there is no way that things can go wrong, because you just give it one opportunities. You give it just one way to do things. It's very important. Yeah, here we are clamping the projection and bonds of the line. Notice that, like, if you've been part of the previous two courses that we did about TypeScript, I feel like looking at these utilities, you might think these are very easy to grasp comparing to what we see. We see a lot of const here that we saw in that we see a lot of const variable that we saw in the previous episodes. We see this dot, which is something that also we looked into. We see how to create functions, private functions, and we see how to reference all these inputs here in the beginning. So you are applying 100% of what you learned in those previous two tutorials. Now we have snap to plane. Snap to plane is very similarly, but actually gets the plane normal and then project that object that you are moving to that normal direction only in the boundaries of the plane, if you are taking care of the boundaries. I think we are not actually doing it here. I think this is more, yeah, in fact we are actually not tracking, like if we are exiting those boundaries of the plane, we just care about the plane. So just so you know, it's a little bit more, oops, I'm having some issue. Okay, that's what I wanted to do. Okay, so the reason why it's working just sometimes is because whenever we are farther than a certain distance, it stops tracking. So we just make it in a way that we need to be very close to the plane to keep things like projected. Well, thank you for sticking with me through these 3 chapters for learning TypeScript in the context of Lens Studio. I hope that you have the basics for getting started on building incredible projects. Just remember that these samples that we showed you here, just remember that all of these resources that I just showed are available in this repository called Spectacle Samples. You see a lot of projects which are also a lot more advanced and make use of all of these things that we went through, looking at just like generally TypeScript code, how it works, and so on and so on. So subscribe if you liked all of this content. Feel free to drop some comments and tell me what you would like to learn or how your journey is going to Lens Studio, and see you next time.